Welcome to back. Now we will talk about the case study in chapter 5, and the page number is 148. We will discuss how to use the for loop or the while loop to help us find the greatest common factor. So what is the common factor? For example, we find the two numbers. Which number can divide it to both numbers, all the numbers together, and the remainder is 0. So we can find the greatest one. For example, 4 and 10 that also can be divided by 2 without any remainder, right? So the 2 is the greatest common factor. So assume that there are two input integers. One is n1, the other one is n2, respectively. So the user can input the integers. And we can find there is a number. One is the common factor because n1 can divide it to n1. N1 can divide it to 1. N2 can also divide it to 1. So it's a common factor and without any remaining. The remaining was 0. But not necessarily the greatest common factor. So the greatest one is which can both or all divided all the numbers, but here is the greatest, right? So we can check whether the k, we will set a variable we call k equal 2, 3, 4, and so on, is the common factor of n1 and n2, but we don't know whether it is. So we will check it. And when k can divide it to n1 and divide it to n2 both, okay, respectively, then we will find the k is the greatest one, which is greatest one. And when will it stop it? Because the divisor have to be smaller or equal than the number. So until k is greater than n1 or n2, then the while loop will stop. And we store the common factor in the variable, named the GCD, greatest common divisor, or yeah, sometimes we'll do that, greatest common divisor or greatest common factor, right? So the initial value of GCD is 1 because 1 is common factor, and then we will try, yeah, until a new common factor is found, then we will replace the position of the GCD, I mean the variable, and it will be also become a new GCD, and until the k is greater than n1 or n2, then there's no chance to be the common factor, then the loop will stop, right? So after checking all possible common factors from 2 to n1 or n2, because we don't know which one will be the smaller, because when the users input n1, n2, we don't know that, right? And the value of the variable GCD now is the greatest common factor. So we will try to see. This is the algorithm here. This is the concept can be transformed into the following loop content. First, we will set the GCD initiated value is 1, and then we put a variable called k, right? Because k will try from 2 until, because we don't know which one will first come, the smaller or equivalent k, because while the k smaller than n1 and n2, then we can do the following check. The following check is n1 have to be, remainder k equals 0 and both, and to also remainder k equals 0. Then we will set the k as the GCD, yeah, a new GCD. Then we will find the next k, because this is while loop. If you do not change the k value, that will become the a limit, infinite loop, right? So this is some numbers, then we can check whether it is the greatest common divisor or common factor. Okay, first integer is 125, sorry. And the other is 2,525. Then we will find the common greatest common divisor for the both number is 25. So we will try to do that. Yeah, we can do that by loop. And it should be the while loop because we don't know which one will be first phase because when the user's input, we don't know that, right? So just like what we say, we will say the number of code GCD. Okay, so I think the options can adjust the font size because last time we talked about the multiplication table, right? Okay, so now k equal 2 because we will find it from 2, right? And we also want the users to input something. So actually we want the N1 become a user can input, right? Yeah. And we want the user input. So the first integer is common, right? And this is the other one for N2, right? Okay, so this should be changed the second. While k smaller and equivalent than N1, and k also smaller equal than N2. Yeah, and we will check if the N1 divided k and equal 0. Yeah, and both N2 divided k also equal 0. Then we'll make the GCD the replaced like k, right? And no matter, so the the k have to be change the value. Yeah, here. Because no matter whether the k is GCD, we have to increase the value of the k. Otherwise, we can't have the chance to quit the loop, right? And so when the loop is quit, then we will print yeah, the greatest common factor of, right? Okay, because common in the print will represent the spaces, and N1 and N2 is, yeah, GCD here. Try. So we'll try it. Okay. First is 125 and the other one is 2,525. So the greatest common factor of each one is 25. So we can also check out the other one if the situation is prime number because it is just for one on itself can divide it by the number, then we can find the greatest common factor was still 1 because nobody can replace the position. So the GCD will still be 1. So the algorithm here is also makes sense. Now it's your turn. Please try it by yourself.